see.
Yeah.
All right, this is section 2.5. This is inequalities. I've written this homework assignment up here. There you go. Inequalities is the title of this section, and every time we do this, I say inequality means not equal, right? That's what inequality means. Not equal. And if it is not equal, what is it?
Unequal.
It's unequal. So it's not an equal sign. What is it if it's not an equal sign?
An inequality sign.
What is an inequality sign?
Less than, greater than, and less than or equal to, greater than or equal to.
Yes, less than, greater than, less than or equal to, greater than or equal to. When you're plotting these on a number line, you might have to do that for a couple of the problems. If you're doing greater than, this is an open circle. To the right. If you're doing, less than. That was less than. Less than is an open circle to the left. Greater than, this is an open circle to the right. Okay? Less than or equal to is this way. Greater than or equal to is this way. Okay? So all that's saying with the equal to symbol is it's saying we can physically have that number that we're at, right? The open circle means we cannot have that number, right? Not that number exactly, but everything larger than it or smaller than it, okay? So that's what that is. For the most part, these are going to be pretty easy. And then we get to the hard ones that you have to do a little bit more work on, but we'll get there, okay? So I'm going to skip down to interval notation. This is a really important thing that we use a lot in this math class. And if you guys take calculus, you know what interval notation is already. But you didn't know it was called that, okay? So interval notation. Here's an example of interval notation. I'm going to give you some examples over here, and we're going to write them down. Let's say that I have a number line, and here's the number 3, and we're going open circle. You can't tell that that's an open circle. Open circle to the right. Okay, I'm going to give you that example. We'll go 4, and we're going to go closed circle to the left. Okay, and then we're going to do something like this where we have, let's say, 3 and 7, and we'll do this one is open and this one is closed, and we'll do one of those. Okay, I'm going to write out what the interval notation is for each one of these examples.
Is this the brackets?
Okay, this is the brackets parentheses things. Okay,
I hate this.
All right.
Yay.
So we have those 3 examples. This is the best way of teaching you interval notation is just to look at what each one of them is. Okay, interval notation kind of looks like an ordered pair. All right, I'm going to do this bottom one first because this is the easiest one to do. Okay. So it looks like an ordered pair, so we're going between 3 and 7. So we do 3, 7, okay? If it is including the number, you use a bracket. So bracket is kind of like a closed circle. A parenthesis is kind of like an open circle, okay? So you use brackets when you have closed circles, parentheses when you have an open circle. Bracket means equal to, parentheses means not equal to, okay? So around the 3 and the 7, we would put parentheses 3, 7 bracket. That is interval notation for that thing, okay? If we were writing it out in what's called set builder notation, this would say 3 is less than x, which is less than or equal to 7. That's what it would look like with the x's and stuff, okay? I personally think interval notation is nicer, right? Because you don't have so many symbols and it's less to do, right? But it looks like an ordered pair, but it's not an ordered pair. Parenthesis 3, 7 bracket. Yes? Okay, now this guy, we'll work our way up. This guy says x is less than or equal to 4, right? That's what that would say, right? X is less than or equal to 4. And then we have to figure out in interval notation what that looks like. But we don't have 2 numbers, and that's the problem.
Infinity.
Right? So it's going forever to the left, right? 4 is my last number. It should go second because that's the furthest to the right that it goes. But we don't have a number that goes to the left side because it goes forever.
Bracket.
So we put
infinity.
You're close. You're kind of close. You're kind of close. The number that is forever to the left
Negative.
is negative infinity. Okay?
Oh, this.
4 is the furthest to the right that it goes. So we put 4 on the right side. It goes from negative infinity. Now, can you touch negative infinity exactly?
No.
So we use a parenthesis. It's like an open circle. We can't touch it exactly. We can't touch it. We can't get it exactly. Are we touching 4 exactly?
Yeah.
Yes, so that one is a bracket. Okay? Now let's do the one right above that. This is saying x is greater than 3. Okay? So in that one,
3.
how does it go?
Bracket.
3 is the first number because that's to the left, right? And infinity, positive infinity goes over there, right?
In both parentheses.
and both of them are parentheses because this is an open circle and we cannot touch infinity exactly, right? Okay? Anytime you have infinities, we'll always have parentheses. Yes, Maya. Yep. Good? Because you cannot touch infinity exactly, right? It's not like one number that you can physically touch. Good? That is interval notation.
Okay.
That is all interval notation. These are interval notations. These are set builder notations, the ones in black. That's what we've been doing thus far. Now we're switching to interval notation. I like interval notation better. Okay? All right, let's go down here. We have example 1. We are solving this thing. Okay? And this is a compound linear inequality. Okay? We have like 3 chunks to it. I have like 2 sets of inequalities. And all I'm going to do is like do the 2 cases. Okay? So here's what this looks like. I've got this chunk here where I have 2 is less than or equal to 3x plus 5. That's the first thing that I'm going to look at. But then at the same time, I have 3x plus 5, that's that middle piece, is less than 2x plus 11. I have those going on at the same time. So I'm going to separate them into pieces. Yeah?
What?
Yep. So the middle piece gets chosen for both sections, right? I do the first chunk, the first inequality, and then I do the second inequality.
So you'd have to take 5 minus 2 on the first one?
So this first one we're solving for x. So just worry about solving for x. We would get rid of the 5 first, so we would subtract the 5 to the other side, right? Negative 3 is less than or equal to 3x, and then we would divide by 3. So negative 1 is less than or equal to x. If you are one of those people that doesn't like the x to be like second, this would say x is greater than or equal to negative 1. That's kind of what it looks like flipped around. So either one of those answers is technically correct.
So these are going to be 2 separate answers?
Okay, just wait. I'll show you when you put them together and when you don't, okay?
Why didn't you put the sign divide by negative?
We didn't divide by a negative. We subtracted 5 over, but we never, the 3 that we divided was a positive 3. You see that?
Oh,
Yes,
yeah.
we never divided by a negative, correct. We only flipped the sign when we flipped it around, right? Okay. All right, now back over here. Now we've got 4 pieces and we've got to put stuff together. So let's subtract the 2x.
Minus 5.
Can I subtract the 5 at the same time?
Yes.
Okay. So x is less than 6. Okay, and that's great. Now, when you put them together, so we had them apart now we're going to put them together. We have x is greater than negative 1, greater than or equal to negative 1. And x is less than 6. Can you be greater than negative 1 and less than 6 at the same time?
Yeah.
Yes.
Okay, if you need to draw it out. Here's negative 1. X is greater than or equal to negative 1, but x is less than 6, so we have that going on, right? That's what it looks like, okay? So what we're going to do is we're going to write that solution in interval notation, okay? So negative 1 comma 6, and then what?
Bracket parentheses.
around that one in
Parenthesis,
Oh, whoops.
then, oh, no, wait, you're right. Bracket paren, yep.
Okay. I was a little concerned.
Yeah, good? That's what it looks like. Because those are a joined region together, so it has one solution, and that's the solution. Okay, good?
Yes.
All right, next one. This one is nicer than the other one was because you only have one x in the middle, right? So you could technically tackle this all at the same time. Like I'm still going to separate it into 2 pieces. I'm still going to do this because we're going to end up flipping the sign anyway. So I'm just going to separate them. There's the first piece. Okay, there's that first chunk. The second chunk, we're going to still separate into 2 pieces. We could technically leave it, but I'm going to separate them.
So if we divide by a negative, we have to
Yes, if you divide by a negative, you still flip the sign. Yep. Okay. All right. So, are we clear how you break it apart?
Yes.
Right? I kind of color coded it for you. Okay. Next. All right. Here we go. Let's do what first? Minus the 3. 4 minus 3 is 1. Oh, less than negative 5. X. Divide by negative 5. So negative 1/5 is greater than x, right? We flip the sign. Or x is greater than negative 1/3. Okay? That's 1/5. I don't know why I said 1/3. 1/5. That's a 5. That's a 5. I can't read my own handwriting. 1/5. Let me fix it. 1/5. There we go. Okay. Over here, same thing. We're going to subtract the 3. Negative 5x is less than 15. Divide by negative 5. Divide by negative 5. X is going to be greater than negative 3. And there is that. Okay. Now, I'm going to graph this just so that we can see what it looks like. Which one comes first on a number line?
Negative 3. Negative 1/3.
Negative 3 is further to the left. Okay. I will never forget this. Trent Court, like 4 years ago, whenever he was in Algebra 2, he never was in Trig, but he was in Algebra 2 when we did ones like this, and I will never forget it because it traumatized me. And he would do things like, it wasn't even fractions. It wasn't even fractions. He would do like 7 and negative 5. I'm like, child, come on. What are you doing? What are you doing? Put them in order. Come on, let's go. So, negative 3 and negative 1/5. I mean, if you switch those around, I understand maybe, but get them in the right spot. Okay, so this one says x is greater than negative 3. Yeah? X is greater than negative 3. So we have an open circle going this way. And x is greater, is that right? No.
No, you should have that the other way. No.
Yes. No. We already switched it.
Cause you.
Oh yeah, yeah. This one should be less than because I flipped it. I flipped it on accident. X is less than negative 1/5, right?
Yes.
And they're both open circles. So do we have one region joining together?
Yeah.
Yeah. So I can do negative 3 comma negative 1/5, and I do parens around both, right?
Yeah.
And there's that. Okay. Beautiful. Here eventually will we get regions that go opposite directions. I'll show you what that looks like. You're gonna have 2 sets of interval notations in one answer.
Alrighty.
Okay, we doing good so far? Okay. Oh heavens. Let's do example 4 and then we'll do the calculator part. We'll see. Well, let's do example 4 first. Solving a quadratic inequality. Yeah, let's do this one first. Okay, so quadratic inequality. I have to break down that quadratic, and I'm trying to think he's a complex trinomial, but I'm trying to do like 2 and negative 4 is negative 8. But what can you multiply to get negative 8 when you add them give you 3?
No.
I can't think of anything.
No.
Okay, so what do we do now?
Quadratic formula.
Quadratic formula. Okay, so negative b plus and minus the square root of 9 minus 4ac all over 2a. Okay, and we're going to solve this all the way out, and we're going to get 2 decimal numbers.
Alright.
Okay, so negative 3 plus and minus, let's solve this stuff in here. Negative 4 times 2 times negative 4, is that going to be positive or negative?
Negative. Negative 8 times negative 4.
So it would be positive 32.
That's what I meant.
Positive 32. So plus 32, but then we have 9 on the end of it, so that is the square root of like 41 all over 4. Okay, the square root of 41 is going to be a number. I don't know what that is. Actually, I'm just going to do,
I definitely might have done that.
I'm going to do negative 3 plus the square root of 41
Well, I
divided by 4. And I just did the whole thing, the plus side, and it is 0.85. And the negative side,
I got negative 6.2.
negative 2.35.
How? I know how I did that wrong, but I don't know how to fix
I
it.
didn't get that.
0.85 and negative 2.35. What? How'd you do what?
Negative 3
Plus the square root of 42.
So I need
41
it as a fraction. How to make that a fraction?
divided by 4. You don't want the
Okay,
minus
now the
4.
way that you have it entered there is only
So
taking
I
the square root of 41 divided by 4. Okay, so if you're going to do that, you either need to put parentheses
It
around here
can't be, or else just enter.
or just do the
Or just do this here.
alpha y
I
equals
never put it in the fraction.
negative 3
Oops.
plus the square root of 41 all over 4.
I do this,
Okay, and then,
and
you
then
can
I
go
divide
back up,
by.
and you can go just change that for a negative.
Oh, okay.
I don't put it in
Okay.
this fraction.
All right, good? Those are my 2 numbers. Now, since this is a quadratic, and we have 2 answers here, and the symbols kind of get jumbled around, right? So I have 0.85. No, wrong. Trent Court. Wrong Trent Court. Negative 2.35. And